Today I'm going to show you how to do swipe detection with the new input system in Unity for touch for mobile. So for example, if we swipe, you'll see that there's a debug ray drawn here in the scene in that direction. And you can see that when we swipe down, the console.log prints out swipe down. We can also do up, left, and right. And you can use this if you want the player to swipe in a specific direction, or you can just do a general swipe in whichever direction. And I'll also be showing you how to add in this trail renderer, so that when you swipe, there is a tiny trail that follows the swipe, which a lot of games do. And you can customize it to your own liking. Awesome, so let's get started. So if you haven't watched my previous video, I recommend watching that one first. It's how to use touch with the new input system. I show you how to set it up with your phone and how to do a bunch of stuff with the touch. And for this video, we'll actually be using a lot of the parts from that video, specifically the input manager. All right, so the first thing that we want to do is make an input action asset. So go to scripts, right click, and create an input action. And we can just call it player controls, or you can just call it touch controls, whichever you want. Let's add in an action map here. So I'm just going to call this one touch. So an action map is just a grouping of actions, which are our controls. And then our actions are our controls. So we need to keep track of two things, whether we're touching the screen or not, which is a Boolean, and our current position of that finger. So let's make one for the Boolean. So I'm going to call this one primary contact, which means the primary finger is the contact. And we can just set that to pass through and button, or you can just leave it as button. And pass through is if you have multiple streams of input and you don't want to perform a disambiguation between them. So whatever comes in, you'll accept that input from whatever kind of control, whether that be a gamepad or the touch screen, or maybe a different finger. So you can set it to either button or pass through. It won't really matter for this. And for binding, let's go to touchscreen, and for primary touch, which is our first touch, we can do touch contact, which will return a Boolean if you're touching the screen. And let's add another one. Primary position. This will be a pass-through action with a control type of vector2 for our position. And for our path, go to touchscreen, primary touch, and click position. And now we can just save the asset. And this will actually return the position in screen coordinates. So we'll have to convert it to world coordinates if you want to actually map it to use the correct coordinates that your game is using. All right, and so let's click that input action and generate C# class and click apply. I have a ton of videos on the input system, links in the description if you're interested in learning more. All right, so let's make an input manager, right click, create C# script, call it input manager. This script will kind of be like the one I did in the previous video. So if you did the previous video, you can probably skip ahead. Timestamps in the description. All right, so I can just delete these two using statements. I'm going to delete the update and this comment. So now we can say private player controls, which is our script we just generated. Then in an awake function, we can say player controls equals new player controls. On our onEnable function, we can say player controls.enable. Same with onDisable, player controls.disable. And then we have to subscribe to our events. So we want to subscribe when we start pressing the screen, because when we start pressing the screen is when we want to start measuring our position of the finger. So we can say player controls.touch, which is our input map, and then we can say primary contact. And then we can do started. So when we start pressing the screen, then let's pass in the context, which I'll explain that in a second. And let's just call our function that we've yet to make. So let's call that function start touch primary. And we can pass in our context into that function. So we're subscribing to the event and we're passing in the context of that event, which is the information regarding our touch. And then we're going to call this function. And so let's just copy that. And instead of started, let's put canceled. And let's put end touch primary. All right, now let's make that function. So private void start touch primary. And let's take in our input action callback context. So for that, we actually need to put here using Unity engine .input system. And then here we can take in the input action .callback context, and let's just call that context. From our input manager, we'll shoot out events so that other scripts can subscribe to it easily without having to reference this script directly. And so I did this in my last video. So let's just make a couple of events up here. I like to make a region of events. And we can do public delegate void start touch And we want to pass in two things. We want to pass in our vector2 position, our current position, and we want to pass in the time that we start pressing the screen, because we want to measure the time between the swipe. Because if the swipe takes too long, then it's probably not a swipe. It's just the player dragging their finger along the screen. So let's just pass in float time. And so the delegate delegates functionality to another script, so the other script will handle the functionality once it's called. And we can say public event start touch on start touch. So this is what we'll actually call in the script. And I go over this in my other video if you're interested. And same with the other one, which I'll just copy. Instead of start touch, we do end touch, and we just replace those. And I realized I put on start event instead of on start touch here. So here we can say if on start touch does not equal null. So if something is subscribed to this event, that means we'll actually send out that event, because we don't want to send out an event to nobody. So if it's not null, then we can say on start touch, and then we can pass in our position. So if you want to use world coordinates directly, I actually like to make a util class. So you can right click, create a new C# script called utils. And then here you can just say public static, and we're going to return our vector 3. So this is converting from screen to world coordinates. So you can put screen to world. And since this is a static function, we'll just take in our camera here, and we'll also take in that position. And so then we can just return camera.screen to world point. And let's pass in our position. And so for screen to world point, I'm going to make the position.z-axis equal to camera.near clip plane. And this is because for screen to world point, the z-axis has to be the distance that object has from the camera. But since we're not actually clicking an object, which is where you'd need to have the correct position, we can just use the near clip plane if we're in 2D coordinates. So if you're in 3D coordinates, I actually recommend screen point to ray. And so I have a whole video on this, which I'll also put in the description if you're interested in learning more. But in this case, we can just set it to our camera near clip plane. And I can erase these two using statements. And so since it's static, now here on the on start touch, we can just pass in the utils dot screen to world, and we can pass in a camera, which we'll need a reference to. So private camera, main camera, and then in the awake function, you can say main camera equals camera.main. So we're just getting a reference to our main camera, and then we can pass in our main camera here, along with our start position, or the current position of our finger, which is player controls dot touch dot primary position. And then we have to do dot read value, and we have to read in our vector2. And that casts a vector2 to a vector3 automatically. And the last parameter that we need for the on start touch is our time. So we can do that by context dot time. Or you can do start time, since this is the time we started. And we also have to cast that to a float, since this is a double value, and we're taking in a float here. All right, so then let's just copy that and paste it down here and call this one end touch primary. And instead of on start touch, we can do on end touch. And here, instead of start time, we can do context.time. And one last function I want to add is a public vector2 primary position, which will return the position of our finger. And we'll use this for the line render, so that we can tell the line renderer where our mouse is at all times, so that it can change accordingly. All right, and so this will just return utils.screen to world and pass in the main camera, and we can just actually copy these values. Player controls.touch.primary position.read value vector2. All right, and now for the fun part. Let's right click and create a new C# script called swipe detection. All right, and then I can delete this generic using statement here, and I'm actually going to erase all this. All right, so the first thing that we need is a reference to our input manager. So in the previous video, I made it a singleton, which I have another video on. And for the sake of simplicity, I've already imported this script in. So in my input manager, I can just put it singleton and put it input manager. And now I can access it anywhere without a reference. So here we can say private input manager. All right, and so then we need the reference to our input manager. So input manager equals input manager.instance. And so we have to make sure this doesn't run before our input manager. So to avoid that, we can put the default execution order to about -1, which means this will run before any other of our scripts unless we specify otherwise. And so now let's subscribe to our events. So on enable, On disable, we can do input manager dot on start touch plus equals, and I'm gonna make a function called swipe start. And we can do the same for on end touch plus equals swipe end. And then we have to make sure to unsubscribe from these events when we disable the script. All right, so right here, we just copy the same thing and then replace the plus with a negative. And now let's make those functions. So private void swipe start. And we have to take in the same parameters that we shoot out with the events. So that's vector2 position and then float time. And you can copy that, and instead of swipe start, you can do swipe end. All right, so let's detect our swipe. So we want to detect our swipe, our direction, after we've lifted our finger, because we have to know the end position of our finger in order to know what direction we swiped in. So in the swipe end, this is where we'll call our detect swipe. We'll have our detect swipe here. And we'll actually have to store our position the first time and the time as well. So right here we can say private vector2 start position, and we can say private float start time. And in the swipe start, we can just say start position equals position and start time equals time. And we're keeping track of the start and end time to make sure that the swipe didn't take too long in between. And so let's actually make 2 more variables to make our lives easier. One for end position and one for end time. And so I'll just copy these here and put the same for swipe end, but instead of start position, we do end position, and instead of start time, we do end time. All right, so now let's detect our swipe. And remember, we already have this in world space coordinates, luckily, since we called our screen to world point. So we want to measure the distance between our ending and our start position, and we want to make sure that distance is large enough. And we also want to measure the time between that. So if the time is too long, then it's not really a swipe, but if it's a good amount of time, if it's less than, let's say 1 second, then we can consider that a swipe. So up here, we can set up private variables for our thresholds and do a serialized field so we can access it in the inspector. We can say private float minimum distance. So this is the minimum distance that it has to travel. And so I actually have 0.2 here. And then private float maximum time. So this is the maximum time that a swipe can take. And I just put it to 1 and make sure that's a serialized field. All right, so here we can do if vector3.distance. So let's measure the distance. If the distance between the first one, so start, and the second one, end position, is greater than or equal to our threshold, which is minimum distance, and I'm going to start on the next line here so it's easier to read, and our end time, which is end time minus start time. So this is the difference in the time. So if this is 2 and this is 1, then our swipe took 1 second. So if our time is less than or equal to the maximum time, then we can detect this as a swipe. All right, and here we can draw a line, debug, draw a line from the start position to the end position. We can make color.red to make it visible, and then we can make it last 5 seconds. All right, so now you can right click and create an empty object, and I usually like to call it managers. All right, and then in the manager, we can add in our input manager here, and we can just add in our swipe detection here. And we also want to make sure to go to Window, Analysis, Input Debugger, and then here we can go to Options and Simulate Touch Input from Mouse or Pen. So that means we can use our mouse to simulate our finger. And unfortunately, you can only do this with 1 finger, of course, because you have 1 mouse. So if you want to test 2 fingers, you're going to have to build to your phone. And then I actually forgot something. So in the input action, in the primary contact, I forgot to add in the interaction. So click this plus sign and click press, which means that this will be performed when we press on the screen or on the touch screen. So when we start pressing, it'll call this started one. And when we're done pressing, it'll call this canceled one. And so make sure to save this one, and it'll generate the script for you again automatically. All right, and now when we swipe down, you'll see that you can see in our scene, the swipes are showing up correctly. Awesome. All right, so now let's do the directions. So let's determine what direction we're swiping in. So we can do a function called private void swipe direction. And let's actually pass in the direction here. So vector2 direction. Now let's call in our swipe direction. and we have to pass in our vector 2. So to get our direction, we just subtract the vectors. So we can do vector 3 direction equals end position minus start position. And so this will cause the arrow, the direction, to point towards the end position from the start position. And so then we can make a new vector 2 instead. So vector 2 direction 2D, make our lives easier here. We can do new vector 2 and pass in direction.x and direction.y. And let's actually do a dot normalize on this. Dot normalized. So this returns the vector from 0 to 1 instead of maybe 0 to 100. Since we only need the direction, we don't really need to know the length of it. And so here, let's just pass in that direction 2D. Now to detect the direction we're swiping in, we're going to be using something called the dot product. And the dot product is this fancy equation. It's just the cosine between these two directions. But luckily Unity has a built-in function we can use. And so this determines how alike in the direction these two vectors are in. So if they're pointing in the same direction, it'll return a 1. If they're pointing in opposite directions, it'll return a -1. If they're perpendicular to each other, it will return a 0. So we can say if our direction that we swipe in is maybe 90% alike in the same direction, so 0.9 and above, then we're swiping in that direction. So here we can say if vector 2 dot dot, that's kind of funny. And we can do a vector 2 dot up, so this is the up vector. And we can just compare that to our current direction. So if this result is greater than our threshold, so let's just do direction threshold here, then we can do debug.log swipe up. Now let's go up here and do a serialized field to do our private float direction threshold. And let's set that to a 0.9. And since this can only be a value between 0 and 1, we can add in a range here and make sure it stays between 0 and 1 here. And here I misspelled swipe direction, so I'm just going to fix that. This is just the same thing for all the other 4 directions. Or if you want to add in your own direction, you can do so. So instead of vector 2 dot up, we can do down. Here we can do left, here we can do right, and then swipe left, and then swipe right. And if you only want to swipe in one direction and make sure it's not doing it in multiple directions, even though it shouldn't if your threshold is rather high, but if it's not that high, it might show up for multiple debug.logs. So if you're swiping kind of diagonally, it might show up for up and left or right. So we can do an else if instead, so it'll only execute one of these. And it will have the preference of executing the ones at the top, of course, since those are the first ones in the list. Alright, so we can go into our console here and we can swipe down and you'll see that our swipe detected gets printed out. And we also have a swipe down, swipe left, swipe up, and swipe right. So let's see, if I do a bunch of turns here and I release it too late, then nothing will be printed out. And if I press down and let go, it won't print out either because the distance isn't great enough. See, I only moved it a little here and it printed it out, so maybe you want it to be a larger distance. So yeah, that's how to do basic swipe detection. Alright, and so now I'm going to show you how to add in a trail render, so to give the player some visual feedback that they're actually swiping. So let's just add a new game object, call it trail, and then just add in a trail render. So for the trail render, we can adjust the width. So this is the start, so we can make it maybe 0.3. And we can add a point here by double clicking, and we can either make it bigger, but I like to make it smaller towards the end. Then the time is how long the trail lasts. So you usually want to put this to a small time so that it doesn't stay too long. So maybe 0.2. And this is the minimum distance between the points to spawn it at. So I think 0.1 is a good value so that it looks smooth. Then you can set the color and the material. For the material, I've already made a material, trail material. So I just right clicked and create a new material. And then I went to shader, unlit, and selected color and just made it red. So for the trail, you can actually just drag in your material there. And you can unselect receive shadows if you don't want it to have shadows, which I don't think it should have shadows. And then you can make the ends smoother by adding in end cap vertices. So 4, so it makes it rounder. And you can do that with corners as well. So you can add in a 3 there. So then in our script, swipe detection, let's add in a serialized field here. So then in swipe detection, we can add in a serialized field here, call it private game object trail. And so we're actually going to be moving the game object because the trail moves with the game object to make our lives easier. So then here on the swipe start, we want to start this event. So we're actually going to make a coroutine for this, which is just a function, basically, that executes based on certain conditions that you give it, which I'll show you in a bit. But first we want to make sure trail.setActive, so we want our trail to be active, true. And then we want to set our position, so trail.transform.position equals to our position. And when the swipe ends, we can do trail.setActive to false. So the game object is now false. And now we can start our coroutine, which will be doing a while loop inside of the coroutine, and this is to avoid overpopulating the update function. It's kind of the same thing that we'll be doing. You can do it in the update, but I don't want to have a lot of if statements everywhere. So we can do a private IE numerator trail, and then we can do while this is true. So this is just a while loop executing on every frame. So every frame we're going to set the position of our trail. Then we can say trail.transform.position equals our input manager dot primary position, which is pretty simple. And so we actually need to start this. So in the swipe start, we can do start coroutine. We can just pass in trail. You can also pass in the function as so if you want. And then we actually have to end it when we end our swipe, because this will be called regardless if we're in this while loop. When we lift our finger, this swipe end will be called. So up here we can actually store a reference to our coroutine, private coroutine. And then here we can do coroutine equals start coroutine. And then in the swipe end, we can do stop coroutine. And we can pass in our coroutine. And so we actually have to make sure to do something very important, which is in this while loop, we have to make sure to do a yield return null. And so usually when you have a coroutine, you want to make sure to have at least one of these yield returns, whether it be null, whether it be wait for seconds, maybe wait for a couple seconds. For example, yield return new wait for seconds, and you can pass in 3 seconds here. And it'll wait 3 seconds until continuing to execute this function. So for example, anything past this line here will only execute after these 3 seconds have passed. But in this case, we want to do a yield return null because this will just wait for the next frame to continue execution. And we want to make sure that this is executed only once per frame. All right, and so then in our manager, we can drag in our trail here and we can press play, and you can see that it looks pretty cool. It's a little long though, so in the trail, you can actually decrease the time, maybe 0.05 if you want, maybe 0.1. And you can make the beginning bigger. So now you have some visual confirmation, and you see that if we increase the time, it takes longer to stop. And so if you want to build this to your phone, which I explained in the previous video, you can just go to build settings, and assuming you have your installs, either your Android or iOS build support, depending on what you have, you can just switch platforms here. And if you don't have a key set for your application, which I explained in the previous video, you can just actually select development build here. So you don't have to set up key, and it's mostly for debugging. And so your device will show up here under run device. For example, I just connected my device and now it shows up here, and I have to make sure to actually switch the platform. All right, and now that I've switched the platform, I can just do a build and run, and then I can create a new folder here called builds and just call it swipe here, and it will build it to my phone. And you can also set up the player settings to put more options such as the app icon, whether you want it landscape or portrait, and I explained more of this in my previous video. Alright, and I just want to clarify that the new input system does not work with Unity Remote. So if you try to use Unity Remote and it doesn't work, well, it's because it's not supposed to. Alright, so now you see I build it to my phone, and when I move my finger around, it follows it. Awesome. Alright, so thank you so much for watching. I hope you enjoyed. And I also want to wish everyone a Happy New Year's if you're watching this in the appropriate time frame. But yeah, thank you so much for your support over this last year. I really appreciated it. I got 3,000 subscribers, which is awesome. And I also broke my first Patreon goal, which is amazing. And so I want to thank all my patrons, of course. Thank you so much for your support. It really helps me make these videos and encourages me to keep putting out good content. I want to give thanks to my new patron, DK. Thank you so much for your support. I really appreciate it. And thank you so much to all my subscribers and patrons. And my Q&A video will be coming up soon, so keep an eye out for that. Kind of like a double of a face reveal, which is interesting. And so yeah, let me know if you have any questions, and if you haven't already, be sure to join our Discord channel, which is in the description. You can post help or chat. And if you're interested in my Patreon, that's also in the description. I offer source code, early access, and an exclusive Discord chat. So thank you so much for watching, and I'll see you next time.